Good afternoon, everyone. I'm delighted to be here today. Finally, we are at the end. I'm Valentina, and I'm the Business Development Manager of Ubiquo. We are a team of computer vision and machine learning experts that 9 months ago have decided to embrace a challenge related to process robustness and quality repeatability within the metal additive manufacturing processes. Our end user is a 3D printing process engineer that works for a 3D printing service. Basically, to make it simple, he needs to convert a 3D CAD into a metal part. It's difficult, it's tough, and on top of that, he doesn't have any control system to oversee the process. Thus, 2 out of 5 job fails. That means that 40% of build today result into a failure. It's massive. We have decided to address this big pain, developing a data correlation analysis system made of 2 main features: real-time defect detection and root cause analysis, all in one platform, thanks to which we are able to guarantee minus 20% of build failure. Even if we save only 1 job, we have a cost saving for our customers of between 30,000 euro and 140,000 euro, depending on the material and on the size of the part, of course. I'm honored to present you Kima, the in-process defect correlation tool made of 3 main phases: data injection, data correlation for the root cause analysis, and the root cause analysis reporting. Now, I want to tell you a little bit about the market. We have got into this because it's a niche, but big market. The metal AM market alone was valued more than 3 billion in 2022 and is expected to have a compound annual growth rate of 30% until 2027. We are targeting mainly the metal AM service provider, and we are confident that we're going to achieve almost 1% of the market share by 2027. Now, the competitive landscape is mainly made of third-party process monitoring software solutions that are hardware-dependent on one side and only focused on the defect detection and not at all on the root cause analysis. Now, behind Kima, there is a complementary team made of business background and technical acumen. Now, you might be thinking, why are we the best team in reinventing process monitoring in the AM industry? Easy. We know the competition. We know how to build profitable business. We have analyzed every single solution out there, and nothing is working. Now, you know what we're doing, you know how we're doing it, and you know what are the souls behind Kima. But you don't know to how we're going to sell and how we're going to sell it. Now, Kima, it's a B2B product, a B2B solution, targeting mainly the industrial IM service provider, the medium and big one. The one that will pay for a subscription fee per machine and for a setup fee per machine model. In the last 6 months, we have gained the interest of our data provider and of one of the biggest IM service providers in the south of Italy, where we are located. Together with them, we are busy piloting Kima. Now, to convert Kima from a pilot into a profitable traction, we need around 900K. Mostly to push the product validation and to spin out the company. Now, I promise you, Kima is going to be the norm in the additive manufacturing industry. We have the team, there is a pain, we have the solution, we have a beautiful product and the potential traction. So please, if you would like to help us in supporting additive manufacturing with a smart control system, come to visit us after the pitch.
Amazing, right on time. So let us begin with questions.
Yes, hello. Thank you for your presentation. One question on the go-to-market. You have not covered that, but and maybe also because you're still in piloting mode. But anyway, what are your first thoughts on the way you be able to?
I've mentioned as main target the IM service provider because they are the ones that are suffering from the pain. But we are figuring out in the month that also the OEM, the original equipment manufacturer, are interested in our solution. They are one of our indirect competitors, but still, they don't have a software solution that is able to detect the root cause of defects. They have the sensors, they have the defect detection, but they don't know how to correlate the data in order to underline what is behind the defect.
So what you're saying is that possibly you'll go knocking on the doors of the OEMs?
We are already doing it, and we are busy piloting with one of the OEM in Italy. It's called 3D4Mac. They built customized machine for special metal. They have asked us to pilot the system, and we need them because we need the data to make the algorithm more accurate. Of course, we're just at the early stages of the solution, so we need data.
Thank you. What you aim to do is to prevent this waste of happening, the failure, right? So as I understand, you analyze the current model that they are to print, and then you detect that, hey, it's probably going to end up in a failure. So what's the next step? Do you kind of suggest what to do, how they should improve their model, or how does what's the action plan for the customer?
Currently, the user will receive a reporting on layer by layer. It will see where is the defect and what is the probability of the cause correlated to the defect. Can be humidity, can be temperature, can be the CAD design, because the 3D printer takes the 3D CAD from the client and needs to convert the 3D CAD in slicing. So it needs also to add some supports, because the 3D printing prints in layers and needs to be supported. So we have seen that many defects come from the 3D CAD. It's a human error. So, and he doesn't know that. So we give him the possibility, next job, to understand how to set the parameter of the machine and if there is a mistake in its job.
Thank you. So my question is about the IDS technology you use, the International Data Space technology used in your solution. So as although it is a technology which is in development now, do you think that in near future it could have the proper impact in data-driven businesses?
Our machine learning assets, I mean, we have the product can be divided into part, the data storage and the machine learning models. We have developed the solution in a flexible way in order also to adapt the same machine learning models to a different kind of analysis, because we correlate data. We work with the data, not with the machine. So we have also seen that there is interest in other segment which is not additive manufacturing that can be where this solution can be applied.
Okay, thank you.
Amazing. Thank you.
Thank you very much.
Great. So,